Notice all their faces, which you should not post on YouTube either. Okay, when you have the same bases, what can we do with the powers? We're going to set them equal to each other, and then we'll solve. So this one I'm going to subtract 3x on both sides, because I need to get them over to the same side before I can solve. What did we say that was? 2/5 is 4/10. And then I think the trickiest one of the whole worksheet was 18. How in the world can I write these so they have the same base? They definitely can't become ones, because 1 to the power of anything won't ever be 2. 1 to the power of anything is 1. It's 1 times 1 times 1 times 1. It's 1, it's 1. It's still 1. Times it by another 1, it's still 1. So we've got to somehow make this 2 to the power of something. It is 0. Most people's brains really, really want this to mean 2 times 0. So we think this ought to equal 0. Isn't that what your brain kind of jumps to? This is something you have to memorize. This is a property that won't make logical sense. I can make it make sense. I can show you the patterns, which I'll do in a minute. So once you rewrite it like that, you can set, 3x equals 0. So once the bases are the same, you can set the powers equal and divide both sides by 3. So here's where that comes from. Here's where that comes from, and I'm just going to use tens because they're the easiest. 10 to the power of 3 is 10 times 10 times 10, which is 1,000. 10 to the power of 2 is, which is 100. 10 to the power of 1 is, so this is the easiest one to see the pattern. It works for any of them. So what is happening as I go down, down, down? Divide by 10. Losing a 0. Dividing by 10. Dividing by 10. So then what would be this one? Oh, wait. I wrote that weird. I wrote that weird. There we go. I wrote that weird. I just ignored it. So any of the patterns that you see are going to create this. So we talked about that pattern also. But I think base 10s, you can see like visually, oh, the zeros are going away. Okay, kind of cool. Make sure your name, your full name is on this gray paper. Let's pass those into the middle. If you were not here, you should watch the video on Canvas. It's life-changing. Just kidding, it's not. Possibly. There's no faces. You can only hear my voice and see what I write on the board. Oh, I deleted that video. FERPA. I hope not. It's a waste of my time. Then I have to video it again. Okay. We have one more lesson from this unit today. And then tomorrow, we will have our practice test. And Friday, we will take the unit test. So it's on all the stuff in that blue packet, starting out with the simple basic equation, but the ones that are over an amount of time, then the compound interest when we take into account all of these types of numbers that might be part of the equation. We will have solving exponents like from yesterday, no, Monday, which was not yesterday, and then the new stuff from today, which is sequences. So get those notes out. We will finish up our packet, and I'm not using this type of notes anymore. I don't like it. I'm going to leave that up there. I don't think the whole point of this lesson is to memorize these equations. I think the point of this is to notice when to use each one of them. Really? Okay. sequences. This is what we're doing today. If it's not a logical sequence, then I don't care. I don't know if that's even funny. Is that funny?
No. I don't understand it. So.
The baby looks angry, though. She's got nice eyebrows. Oh, wow.
That was funny. You're funny.
Okay. I don't create these. Okay, here's what I want you to do on your notes. Come on. Okay. After I find my pen. It's in my pocket. Okay, on the back of your notes packet, so here's the front page. If you go to the back, the top should be filled in. And then I need you to edit this a little bit. So yours says geometric sequence. And it says the explicit equation. So this is already there. I'm just trying to catch up with you. And then underneath it says geometric sequence recursive. We are not using that one. So please cross it off. Just cross it off. And then I want you to write, like there's kind of a space there. I want you to write arithmetic sequence. So down here in this bottom box, yeah, we're not doing geometric sequence recursive equations. We are not using that. So I just crossed out all these things. We still need the room, but we're just not doing those. It's not necessary. No, we don't need that formula. I'm giving you a different one. Arithmetic sequence. And here's the equation for that one. So this is already there. Here's what you need to write down. A sub n equals A sub 1. Why do you think it's called A sub n? Oh, it is a subscript. Like a submarine. It's down below. It's not to the power of, it is a little tiny one, but it's down below. So we say A sub n equals A sub a. I always forget the plus sign on this one. So I'm going to make it a different color. Plus n minus 1 times d. So those are the two equations we are using. This one down here that has a sub n minus 1, we're just not using it. So if you didn't cross yours off, please do so. Okay. I'm going to show you a page with a bunch of different sequences, and I want us to kind of observe them and have a conversation with your neighbor. So you either groups of 2s or groups of 3s. Or Levi, you like to work by yourself, right? Or you can go left or right. So girls next to him, make sure you ask if he wants to work with you. I want you to look at these different sequences and see if you can figure out which group they would be in. Okay? And then second thing I want you to decide is there one that doesn't belong? So when I was a little kid, we'd watch Sesame Street, and there was always one that didn't belong. Okay, so we've got arithmetic, and you may not even know which is which yet. So looking at these different patterns with your table group, decide what are the two different patterns that you are noticing. Okay, so if you need to write stuff down in those margins, do that. I'll give you a minute and a half or so. Do you see two different types of patterns? Okay, go. So am I. I'm a special case. Okay. I'm going to call on some of you to share what you maybe noticed with your partner. We'll start in the back. Sarah, Jetta, and Tyler. Talk to me about this first one. What did you notice about its pattern? How could you go from 8 to 13? Is there anything you can multiply it by? What can you add to 8 to make it get to 13? Does that work going forward? 13 plus 5 is? 18. 18 plus 5? Okay, so we think maybe this has an adding 5. All right, let's move on to the next group. Jose and Lauren, what about 1 to 2 to 4 to 8? What is that pattern? So far we've got an adding pattern and a multiplying pattern. All right, Addison, Page, and Porter, what about the third one? Okay, I like that. Are you raising your hand? All right, Tristan and Macy and Alyssa, what did you notice for the fourth one down? Decimals, so kind of scary. What's it adding? Multiplying. What would it be multiplying by? How many 0.5s do you need to get to 1.5? So try to think of look at the smaller ones. Anytime you're dealing with sequence, I would not start with the bigger numbers. I would start down with the smaller ones we're more familiar with. And again, say, could I add? Because it could have been adding 1 or 0.5 times 1 is 1.5. 1.5 plus 1 is not 4.5, so it can't be an adding one. We think this is multiply by 3. But again, notice how I said that. How many 0.5s do I need to get to 1.5? And everyone's like 3. Okay, this one is a special case, it seems. Grace and Emery and Levi, did you guys figure out, it's not one of these simple patterns, but what is it doing? So we're adding 5, and then we're adding, subtracting maybe? Subtracting 5, subtracting 10, subtracting 15, subtracting 20. That's a very cool pattern. But it's not going to do this. So does anyone have a name for these two different types of patterns with our previous knowledge?
Yes.
What'd you say? These ones are going to be a straight line. If you were to graph them, they're either going to be going up, linear, or down linear. And these multiplying ones are going to be exponential growth. This one is not either one of those. It's going to be curved, right, because it's going up at an uneven rate. But it will not grow exponentially. It's growing in a really organized and a gradual rate, okay? Who did I get to? Delta and Ashlyn, what about this one? I wish these were numbered. By 4? If you're trying to find that pattern, I would not look here. I would go to the numbers that I'm familiar with. I would start with the 1 and go to the 4 and then to the 16. You can go back and double check and make sure it works, but I would not start with weird fractions. I just wouldn't. It's hard to find the pattern. Okay, we've got this decimal one. Jeremy, Mason? No. Oh, I'm not looking. Rich. Oh, it's not even coming. What does it start with? Mason.
Miles.
Oh, you're my other Miles. My Miles and my Miles. That did not come. Oh, sorry, Miles. Okay, hopefully I'll never forget it because that was really embarrassing for me. Okay, Miles, Jeremy, and not Tristan. Tyson. What did you guys notice on this one? Adding 10, adding 10, adding 10. Okay, I think we've done enough. It would be nice if these were called linear and exponential sequences, wouldn't it? Nope, way too easy. We call them geometric and arithmetic. Arithmetic is the adding one. They both start with the letter A. I have no way to remember this one, but this is the multiplying one. So if you want to add that to your notes, so you don't mess them up. Yes, because you can add a -5. So the adding and the subtracting ones go together, the multiplying and the dividing ones. Because same thing with the dividing, we would say multiply by a half or multiply by a third. We don't usually say divide by something. That's a good point. So multiplying and dividing, adding and subtracting. Okay, we're going to do a couple examples. I'm going to show you how to use this. So you're familiar with lots of equations, like y equals mx plus b. And do we ever put numbers in for the parent equation? We put in m and we put in b, but what stays variables? The x and the y. So in these ones, when we put our basic equation in, this is going to stay and this is going to stay. A sub n will stay and n will stay. And we are going to replace things in for A1, R, and D. Okay, in your notes, it already tells you that A sub 1 is the first term. Do you see where I'm talking about? And it says R equals what? Let's come below. For the arithmetic, a sub 1 is the same thing. This means the first term. What do you think the D stands for? This is a common ratio, a common difference, because we're adding or subtracting. It's the difference in the two numbers. So write those two down on that bottom equation, or that second equation. So make sure you write down a sub 1 is the first term still. That didn't change. But instead of an R, we have a D, which is the common difference. Write those two things down. This isn't hard, but if you're half asleep and you don't write it down, you're going to be confused. Okay. I know my voice is so soothing. I actually don't think it is. I feel like my voice is not. Okay. You've got some room out to the side. So let's decide if these are arithmetic or geometric, and then you know where you can put them in your notes. So let's look at the first one. I want you guys to think in your mind. If you can figure out which one it is, go to that section in your notes. Most of you have like some space over here that's empty. Grace, do you need to go get a drink? You're sleeping sitting up. That is so talented.
No, it's your voice.
It's my voice? All right, Bradley, for this first one, is this arithmetic or geometric? Is it adding or multiplying? So which one is that? Yes. So go to your geometric notes. That's the top one. Please write down these four numbers. We're not doing very many examples, so make sure you write these few ones down. We have a lot of worksheets coming up. We have one big ideas on Monday, and then a whole stack of worksheets. No, we'll do one at a time. Oh, I tried that at the beginning, and the kids did. The honors freshmen went through the whole packet on day one. It was a nightmare. Okay, I don't know where I left off calling on people. I should. Oh, I think I'm to Martha. Okay, Martha, what is the first term? It's literally just the first term. Negative 16. And I like to call it a sub 1. If you look at my answer key, I always write a sub 1, because that would be something silly to mess up on. I'm not doing that. Thanks for your suggestion. You want them all at once? Okay, you can come get yours. Ambrose, does this have a common difference or a common ratio if it's geometric? So Ambrose, what is the common ratio for this one? Everyone's answering for you. I must not be saying your name. It is dividing by 2, which is a half. And we usually write it as a multiplier. Yes?
Sorry, what was the common difference and common ratio?
So if this was adding, so like this one, the common difference is 5, because it was adding 5. This one is multiplying, so it's a common ratio. This was subtracting, so the common difference was in minus 5. So if it's multiplying or dividing, it's a common ratio. If it's adding or subtracting, it's called a common difference. We are not doing the recursive equation, right? Yes, we're doing explicit. Doesn't that sound like inappropriate? Isn't that what that word means?
What? Explicit?
Like explicit lyrics? That's the only other place I've seen that word. So I don't know why we're using it right now. Okay. It's a very inappropriate. It's hard to remember.
I think we should learn explicit stuff.
I know, I feel the same way. Okay, so I just wrote down the generic one. Will you please plug in a sub 1 and r? So it will look like this. A sub n stays the same. Instead of a sub 1, we put our negative 16. Instead of r, we put our common ratio. I'm trying to be fancy with the colors. So write this one down because we're not writing very many examples down. So this is the basic formula. This is the formula for this sequence. Now, it always bothered me that it said n minus 1. I really just wanted to say n, like so badly. But I found that if I just use n, so I try to find the 12th term, if I put a 12 here and I solve without the minus 1, I'm always getting one term off. So I was kind of exploring that. Why do I do n minus 1? So just if anyone else is wondering, this is where it comes from. There is a term out here that we never talk about. We never write it down. It doesn't have a name. I know. But in order to find this negative 16, you have to start out here. And then to get the term number 1, bam. Okay? So the n minus 1 is starting out here in outer space, kind of, and coming to the first one. And it's the same idea with your arithmetic ones. It's the same thing. You have to do that n minus 1. Okay, so to find the 12th term, we write a sub 12, kind of like function notation. And anywhere there's an n, we'll put that 12. Anywhere there's an n, we'll put that 12. And then you can punch that into your calculator. Because I don't think I know what 1/2 to the power of 11 is. Yeah. Oh, yeah. Yes. At least one person would say, where did the 11 come from? It's true. At least one person would say. So in the notes, I just write it out really, like, so people can see where it comes from. When you do it on your own paper, I would write an 11. When you punch in your calculator, I would punch in an 11. Okay, are you guys all typing this in? Yep. Some of you don't have calculators. You can go grab them. It doesn't bother me when you get up and grab them. Typing. So Sydney, what did you get for a sub 12? So I like to go up and look at the pattern and see if that makes sense, because that seems like it's negative, it's really small. But is that where this is headed? Is it going smaller? And are they all negatives? So it makes sense. If I'm ever nervous, I go back and I look. And honestly, if you really hate, if you don't trust it, you can just go from -2 and do half, 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 till you've done it 12 times and see if it matches. It's a longer process. Okay. I don't know if that's enough examples, but we're going to do one that's arithmetic now. I hope these are arithmetic. Okay, so check out, we'll just do the first one. Do you guys agree it's arithmetic? Lindy, how would I know for sure if this one's arithmetic or geometric? Yeah, so what do you think it's doing? I think it's adding also. Wow, that just went yellow for no reason at all. Hi. Paige Gurney. Wait, do I have a Paige? Oh. Paige, I don't know your name very well yet. Oh, I don't know two people's names. Miles, Paige. I just have to embarrass myself by not knowing it, and then I'll never forget it. Okay, we think this is arithmetic because we found that the common difference is what? 5. And the first term is 8. I like to call it A1 because that's what it's called in the equation. We're only doing the explicit equation. So this one's a little bit different. I'm going to write down the original one. If you don't make yourself write that plus sign, you're going to forget it every time. I was going to say have fun at your doctor's appointment, but is that something you say? Good luck at your doctor's appointment? Oh, you're going somewhere fun?
Yeah.
Okay, have fun. Oh, yeah.
Thank you.
This is my last one. You do multiply it by D, yes. Okay, so let's plug these in. We are to Tate. What do I put instead of the A sub 1 for this sequence? For my A sub 1, what is my first term? And then please put the plus sign. You are going to get all the wrong answers if you don't. And then everyone puts n minus 1. And what's my common difference?
5.
Once again, the n minus 1 used to throw me off so bad. I wanted it to just say n. But if you only use an n and you try to find the 12th term and then you do like, plus 5, plus 5, plus 5, plus, you will be one off every single time. So that n minus 1 takes into account this term out here that we never talk about. It doesn't even have a special name, but you have to start there to get to your first term. What do you want to call it, CJ? Fred. Okay, n minus 1 is going to get you to Fred. Plus. And yes, Logan, when you're doing this yourself, you're welcome to put an 11 there. Not Logan. Ethan. Oh, man. You guys, I'm having a rough time. I didn't forget his name. I just called him the wrong one. So you can plug this into your calculator. It will give you the 12th term. All right. I'm not sure we're ready, but we're going to hand these out. We're so ready.